Alright, so once again, here's the assignment. If there are problems that you want to see done, they should be written up. I will do 5 problems. There are 4 sections. We're good? Alright. So up first is number 5. So ladies and gents, as you know, earpiece is in, which means that I'm deaf in ear, so please, conversation needs to be as quiet as possible so I can hear those that are giving me information. So what's number 5 say? Okay, so first things first, do we have a fraction, just one fraction on the left and just one fraction on the right? So remember, that's the target that we're trying to get to. When it comes to solving rational expressions, you want to have just one fraction on the left side, one fraction on the right side. Okay, so when I have that, what's my next step? What do? Cross multiply over the equal sign. So I'm going to take numerator times denominator, numerator times denominator. Everybody good? All right, so I'm going to get 9 times x plus 2 equal to 4 times 3x. You're going to distribute. If you want to do it in one step, you're welcome to. And then we just solve like normal. This is a linear equation. We're going to subtract 9x from both sides and get 18 equals 3x. Divide both sides by 3, and x is equal to 6. Nice and easy. Moving on. Number 10. Can somebody read number 10 for me, please, and thank you? Negative 1 over x. All right, so same basic breakout, right? Do I have just one fraction on the left? Yes. Do I have just one fraction on the right? Okay, so I'm going to do my cross multiply yet again. All right, so I'm going to get negative x squared plus 2 equals x squared. Everybody okay with that? Yes or no? Yes. All right, now I have to combine my x squareds. Which one do you want me to move? Okay, how do I move a negative x squared? Add it, so I get 2 equals 2x squared, correct? How do I get the x squared by itself? So x squared is equal to 1, and then how do I get x by itself? Square root. So when you square root, how many answers do you get? 2, so x equals plus or minus the square root of 1, which is 1. So you get x equals 1, x equals a negative 1. All right, so make sure that whenever you see an x squared, I'm getting 2 values, okay? And if they ask you to solve and you get down to here and you don't know how to solve, you might have to use the quadratic formula. Okay, so if we can't factor, then we use the quadratic formula. Everybody good with that? Yes, no, maybe. Number 12, what's number 12 say? Okay. So even with as big and nasty as this thing is, right, there's a couple of different methodologies here. The order doesn't really matter too much for the first couple steps, so it's up to you. All right? So does everybody see that I have one fraction equal one fraction? You can either factor it first and then cross multiply, or you can multiply and then factor. I'm going to multiply and then factor, but it actually doesn't matter. So do I have a single fraction equal a single fraction? So cross multiply, right? So I'm going to get 9 times x squared minus 3x. And those of you that are talking over me right now, you'd better know what you're doing, other than making me upset. No, it's not being times. Oh, wait, you mean in here? Yeah, but we're going to factor everything apart, so we do not want to make things bigger. So what we're going to do is we're going to factor everything out as far as we can for our solving, okay? Because if there's anything in common to the left and the right side, I can just remove it, so that way it makes things more simplistic. Everybody good? So x squared minus 3x, can anything there be factored? So I can pull out an x, and that leaves me with an x minus 3. I have a 3 times an x, and then I can factor this into x minus 3 times x minus 3. Everybody okay with the factoring process by now, I hope? Yes, no, maybe? So is there anything that matches up to both sides, or anything that I can divide from both sides? Okay, so I have an x, I have an x minus 3, I have an x, I have an x minus 3. Is there anything else? 9 and what? So what can I divide into both? 3. So I'm going to put a 3 here and a 3 here. So all I'm doing is I'm trying to reduce everything down. Everybody okay with that idea, yes or no? So how I reduce these is by finding repeated factors on the left and the right side and then dividing them away. All right? So x minus 3 cancels with x minus 3. X and 3, that all cancels off on the right. On the left, x minus 3, and what's 9 divided by 3? Okay, so I get 3 equals x minus 3 out of that big grossness. So how do I get x by itself? So x is equal to, done. That's why factoring is so important, is so you can see what can cancel out. Now, with what you were saying, Julian, if you multiply together up there, you would get a big cubic and then another cubic. And if you got everything to the same side, you should get to the same result. But it's going to make everything big first, and we don't really have a lot of techniques past quadratics. Okay? So usually instead of making things bigger, we make things smaller because we have more tools to use. But if you did it right, you should still get the same place. Okay? I was looking for things that match up on the left side and the right side after I factored. So you see how they both have an x, right? So if I divide this side by an x and this side by an x, they'll cancel out. Okay, they also both have an x minus 3. So I put an x minus 3 underneath of each to cancel. And then I have a 3 and a 9. What number divides evenly into 3 and 9? 3, so I can divide each of them by 3. So all I'm doing here is a reduction after I factored. So any factor that's on the left and the right side, I'm going to divide everything by, so that way they cancel away. So that's what all of the black writing is, right? It's the things that are in common to the left and the right side that I can divide by because I only have multiplication up here, right? That's why I have everything factored in parentheses. Any factor that shows up on the left side and the right side of the equation, you can cancel off by using division. So that's all I'm doing is using division in order to write a more simplistic version of this statement. Is everybody okay? So number 15, what's 15 say? 3x. All right, so do we have a single fraction on the left? No, so that's what we're going to be working toward, right? So I'm going to use the crisscross across method. Like that. Multiply. Get your single fraction on the left. So 2 times 6 is 12, plus 3x all over 18x is equal to 4 over 3x. Get rid of parentheses. Can I combine anything on top here? No. Do I have any parentheses to get rid of? No. So now I have a single fraction equals a single fraction, so I cross multiply. Gesundheit. So you're going to get 3x times 12 plus 3x equals 4 times 18x. Everybody all right with that? Yes or no? If you notice here, I'm going to factor out what I can, right? And I'm looking for things that can cancel from left to right. So do I have anything that can cancel from left to right? Okay, I have a repeated x, so I know that can go. Anything else? Like what's 3 times 3 here? 9. So I can actually just rewrite this as a 9, right? Is there anything over on the right-hand side that 9 goes into evenly? 18. So if I put the 9 here, I know I can divide a 9 here. Everybody okay with that? Yes or no? All right, so the 9's cancel, the x's cancel. 18 divided by 9 is 2, and those x's cancel. So I get 4 plus x is equal to 8. Please check and see if that makes sense, if you follow, if you have any questions. So then you got to finish up, and x equals 4. So any questions left on 15 on the basic process or the targets while you're working? Everybody good? All right. So up next is, wait, was that 15? Yeah. Okay. 21. Somebody please read 21 for me.
2 over x minus 3 plus 1 over x equals x minus 1 over x minus 3.
Minus x over 3?
No. X minus 1 over x minus 3.
Oh, okay. All right. So it seems though I'm hoping by this point these are starting to get kind of repetitive, right? So I'm not necessarily going to be explaining this one. I'm just going to move through. I'll achieve the first goal, which is to get a fraction equal a fraction. We'll check for understanding, and then I'll cross multiply and solve and check at the end of that. Everybody all right? So please get to work and try to follow along. If you have questions, ask. Yeah, I'll write that one out just so that everybody can see what's happening here. Please try this one on your own, and then we'll get back together and check and see what's going on, okay? Alright, so here's the first goal. Have a single fraction equal a single fraction. Any questions on those? Yes, no, maybe, I don't know. Alright, so now that I have a single fraction equal a single fraction, what do I do? Cross, multiply, and then simplify. So, cross multiply. Cancel if you can. Aw, that stinks. Aw. I was hoping things would cancel. Nothing cancels. I wrote +3. Alright, so my work is all wrong. That's supposed to be a -3, not a +3. So none of the steps are wrong, but all of the numbers are wrong. So alright, so this is going to become a minus. Is the other side right? Is it x minus 1 over x minus 3? Okay. So from up here, right, all of these signs have to change on the left-hand side. Yeah, I wrote it as 2 over x plus 3. So it changed everything. As far as the signs go, the actual math was right. It's just the signs are off. And where it's going to impact is when we expand. Remember how I said I was kind of bummed I didn't get anything to cancel off? Well, guess what's going to happen this time? Something's going to cancel off, and then we don't get the cubic, we're going to get a quadratic, and we can solve it. Okay? So everybody recheck your first 5 lines, make the changes as necessary. These are now correct. What's in common to both pieces? X minus 1 and x minus 1. X 5 over 2 minus 1 over x plus 2 over x squared. Okay, so I know the other day several of you were asking me for me to do one of the triple fractions, so I'm going to knock this one out. If you don't have it on your worksheet, please make sure that you follow and copy it down. So it's actually the exact same rules we've been using. Okay, is there anything that's repeated? Now, instead of looking at 2 denominators, we're looking at all 3. Is there anything that I can do to factor 2? What about x? What about x squared? Not really. X squared is x times x, though, right? So I'm going to write it that way for one reason. Okay, is there anything that's repeated? Oh, wait, no, sorry. Is there anything that's repeated to all three denominators? All three. Is there anything that's common to all three of those denominators? No. So that means that every one of the old denominators has to go into the new common denominator. Okay? So let me change this back. I just wanted to do it to show you all that it's the x. So here I have two x's, right? I have an x shared in each of these, but I don't have it in the third denominator, so I don't worry about it. Everybody okay? So my common denominator here is going to be 2 times x squared. When in doubt, multiply everything together. Everything should work out in the wash properly. Okay? So what is in the common denominator that is not in the original denominator for the first fraction? X and x squared. So what am I going to do with the 5? Multiply it by x and x squared. Everybody okay with the first piece? And then I just do that for all three of the fractions. So I'm going to wind up with this as my numerator. Everybody all right with that? So now it's the same process. Multiply, get rid of parentheses, group your like terms, all on top, okay? So I'm going to wind up with 5x cubed minus 2x squared plus 4x all over 2 times x squared. Factor out what you can. The only thing that's in common all three is the x. So I'm going to factor that out and give you a 5x squared minus a 2x plus 4 all over 2 times x squared. And anything that cancels from top to bottom here? Just the x, right? Yeah, because there's no 2 in common for the 5. So your final answer here is going to be 5x squared minus 2x plus 4 all over 2x squared. And that's it.